All right, so now let's look at a second example of one of these quadratic inequalities. So again, we want to bring everything over on one side, and I like to bring it over on the left-hand side. So I'm going to go ahead and subtract x squared from both sides. 2x squared minus 1x squared, there is just x squared, minus 3x is greater than or equal to 0. All right, so we brought everything over on one side. We set it equal to 0. That's not the difference of squares. That's not the difference of cubes. That's not the sum of cubes. So what is that? All right, it is a GCF problem. Pull out the GCF, pulling out the x. I'm left with an x minus 3. All right, so we've been working through our steps here. Step 1 there, we brought everything over on one side there. Brought all terms over on left side. Step 2 that we're doing right now, we're on step 2. So now we're going to, we just factored it. All right, and now we're going to find the factors. So set factors equal to 0, solve for x. So basically, you're trying to figure out our zeros. So first one here, I can set it equal to 0. Second one there, set it equal to 0. Well, x equals 0 is already solved. I can add 3, and I get x equals 3. All right, we just found our zeros. All right, step 4. Step 4 there, we're going to we're going to go ahead and draw out our number line. Put our numbers on the number line, 0 and 3. This time we're going to think through, okay, the problem there says it's greater than or equal to. So now this time, these are actually going to be solid at those zeros because it can be equal to 0 when you plug those in there. So we are figuring out, and we're going to do our test value. So we figured out where our zeros are, and now we're going to test values for step 4. And shade. All right, so let's test our values here. So we're going to pick a value over here, x equals -1, something less than 0. Something in between 1 and 3 there, that's the next section there. You can see the sections are determined by the dots there that you put on the number line. Something in between 0 and 3 there, I don't know, maybe like 1. Something larger than 3 there, oh, maybe like 4. All right, so let's test those values. So again, you can either put the -1 in the original problem, 2 times -1 squared minus 3 times not the original one, I'd probably do the one where it's equal to 0 there. So you could test that one. You could do -1 squared. Make sure you put the parentheses in around the -1 and square it, minus 3 times -1, and see what happens with that value. Is that greater than or equal to 0? So do you get a positive number when you do that, or do you get a negative number? So, or you could put it in your factors. So if I put it in my factors, it's -1, and then -1 minus 3. Well, -1 is -1. -1 minus 3 there is -4. -1 times -4 there ends up giving us a value of 4. Is 4 greater than or equal to 0? Yes. So I'm going to shade in that region. Okay, now let's pick 1. If I put 1 in there, so I get 1 times 1 minus 3. 1 minus 3 there is -2. 1 times -2 there is -2. Is -2 greater than or equal to 0? No. It's less than. So I'm not going to shade in between 0 and 3. Okay, let's check the other regions, things that are greater than 3 there. So we picked a 4 as a test value. So 4 times 4 minus 3. 4 minus 3 there is 1. 4 times 1 there is 4. Is 4 greater than or equal to 0? Yes. So we've got our solution there graphed out. So then step 5, we have to write our solution out. So we've kind of done, I kind of end up doing step 4 and step 5 here together. So now I'm just going to write it out in interval notation here. It goes off through negative infinity. It stops there at 0. It's equal to 0 there, so it's a bracket. Remember, there's a gap in our graph. What do we do with gaps? We put that union symbol in there. It kind of means like it means an or, and then a bracket there at 3, and then goes off forever to the right, which is infinity. And infinity and negative infinity, we both have parentheses around those. So we have come up with our solution there, both on the graphing wise and as in the interval notation there. All right, so I've got 2 of them for you to try right now and see if you can solve these quadratic inequalities here and work through those same steps. So pause the video and try those out. All right, so let's go ahead and let's solve each quadratic inequality and then express these in interval notation and graph on a number line. So my first step here is I'm supposed to bring all my terms over on the left-hand side, set equals 0. So I'm going to do that. So I'm going to subtract 1. We end up getting 2x squared plus x minus 1 squared and equal to 0. That's my step 1. I've just done it. Step 2, we want to factor this left-hand side. Well, it's a trinomial, general trinomial there. So what times what gives me 2x squared? It'd be a 2x and an x. What multiplies to give me a negative 1? Well, one's going to have to be positive, and one's going to have to be negative. So it looks like this is going to have to give me my plus, because a 2x minus a 1x will give me my middle term there of 1x. So that works. And then, so I factored that. Now I'm going to solve and get my values there. So I'm going to find my zeros next here. So I'm going to do 2x minus 1 there equals 0, and then x plus 1 there equals 0. So I can add 1, divide by 2, and we get x equals 1/2. Over here, you can subtract 1, so you get x equals negative 1. So I'm going to divide up my regions now. So my regions here are at negative 1, and then one's up here at 1/2. All right, the original problem there said greater than or equal to. Greater than or equal to, that means it can be equal to 0. So when you put these values in here at negative 1 and 1/2, you're going to get 0 in over on this left-hand side over here after you factored and after you moved your terms over here. So those are going to have closed dots there. We're going to test the regions. So something less than negative 1, something in between negative 1 and 1/2, and something larger than 1/2. You can pick whatever values you want. I usually pick them pretty close to the value, but you can pick really large numbers. Like I could pick negative 100 if I wanted to. I'm just going to pick something close, negative 2. Something in between negative 1 and 1/2, well, an easy number to do is 0. And then something over in this region, maybe like 1. That's something larger than 1/2. So those are my test values. And again, the 2 places up there that have little red marks up there by, you can put it in either one. Again, I prefer to put it in the factored ones. You don't have to. So 2 times negative 2 minus 1. And then we've got the other one here is a negative 2 plus 1. So that's a negative 4 minus 1 there is a negative 5. And then this ends up giving me a negative 1. So if you multiply those, you end up getting 5. Is 5 greater than or equal to 0? Yes. Shaded in. All right, let's pick 0. 0 is an easy one to do. So I'm going to go 2 times 0 minus 1. Put it into my factored ones up there. So into right there. So 2x minus 1 there. So 2 times 0 minus 1, plugging it in for the x. 2 times 0 is 0, minus 1 there is a negative 1. My other one there is 0 plus 1. 0 plus 1 there is a value of 1. Negative 1 times 1 there is negative 1. Is negative 1 greater than or equal to 0? No. All right. So then let's check the last region over there. It's at 1. So for that one, we've got 2 times 1 minus 1. And then we've got 1 plus 1. Well, 2 times 1 is 2, minus 1 there's 1. 1 plus 1 there's 2. So we end up getting a value of 2. Is 2 greater than or equal to 0? Yes. Okay, so we've got it graphed out there. Now all I have to do is write our ending solution there. So let's write this in our interval notation there. So we've got a, we're going off forever to the left. So that's negative infinity. Negative 1 there, we've got a closed dot, so that's a bracket. There's a split in the graph, so that's union. And then we've got a closed dot there at 1/2. And then we're going off forever to the right there, which is infinity. So negative infinity, comma, negative 1 bracket, union, bracket, 1/2, comma, infinity, parenthesis. So around the negative infinity and around the infinity there, we have a parenthesis. All right, letter B. You want to bring all your terms over on one side, so we subtract 2x squared from both sides. We're going to get an x squared minus 3x is less than 4. You have to bring 4 over, so I would subtract 4. All right, so we brought all our terms over on the left-hand side. Now we have to factor this. What multiplies to give me negative 4 and adds to give me a negative 3 there. It'd be a minus 4 and a plus 1. Let's find our zeros and write them on a number line. Well, how do I get 0 there when x is 4? How do I get 0 there when x is negative 1? All right, let's put those values on the number line. So this time, is it going to be closed dots or open dots? Well, it's less than. It's not equal to those zeros, so we're going to put open dots at those spots. All right, pick your test values next. So test values here, in this case, are going to be something less than negative 1, so maybe like negative 2. Something in between negative 1 and 4, so maybe like 0. And something larger than 4, maybe like 5. And again, I like to put it in my factored ones. You could put it into this x squared minus 3x minus 4 as well. So if I do this, I go negative 2 minus 4, and I do negative 2 plus 1. Well, negative 2 minus 4 is negative 6. Negative 2 plus 1 is negative 1. I multiply, I get 6, which is positive. So is 6 less than 0? No. What about putting 0 in there? So let's test 0 into our factored ones there, or into the one above it. 0 minus 4. Let's see if I can erase this and not make a mess. There we go. So 0 minus 4 and 0 plus 1. 0 minus 4, there's a negative 4. 0 plus 1 is 1. Multiply, we get a negative 4. Is negative 4 less than 0? Yes, it sure is. And then if we put 5 in there, 5 back into our factors there, we've got 5 minus 4 and 5 plus 1. Well, 5 minus 4 there is 1. 5 plus 1 there is 6. We multiply, we get 6. Is 6 less than 0? No. So we simply get this kind of between solution. So how do we write that in interval notation? Well, it has to be parenthesis negative 1 because we've got an open dot, and then 4 here ends up being a parenthesis as well because we've got an open dot. So in between negative 1 and 4 is our solution. All right, so there's 5 steps for solving a nonlinear inequality there, so a quadratic. What you want to do is bring all your terms over on left side. So right side equals 0, right? All right, second step here. You want to go ahead and factor. Third step here, you want to find your zeros. So set factors equal 0 and solve for x. Then you want to graph those on a number line, and then you want to choose test values. In those regions that have now just been determined. Choose test values in those regions and test those. To see if they hold true or not. If it's a less than, do those, when you put the test values back in there, does it hold it true? And not. If it does, then you shade that region. If it's not, then you don't change it, shade that region. And then the fifth value here, fifth step here, choose those test values. You test those values and shade regions that hold true. And then fifth step here, write it in interval notation. So those are the steps that we take for solving a linear or a quadratic inequality. So those are our 5 steps. Work through those. They take a little bit of time and they take a little bit of work, but you can do this.